Hello and welcome to this pre-recorded event for GCSE Astronomy, Controlled Assessment Marking. To help you get the most out of this feedback, you may want to have the following documents handy, as we will refer to them during the session. PDF copies of the above documents will have been emailed to you before the session. This is the plan for this event, listing the knowledge and skills which we hope you will take away from it. This is the basic structure for each student's portfolio of work for controlled assessment in GCSE Astronomy. They need to complete 2 pieces of observational work, one with a naked eye and one with some form of optical instrument, such as a camera, binoculars, or a telescope. This is the list of possible unaided tasks from which students select one of their controlled assessment tasks. This is the list of possible aided tasks from which students select one of their controlled assessment tasks. Each CA task is awarded up to 5 marks under each of 4 criteria: design, observation, analysis, and evaluation. This is the assessment criteria for the design criterion. These are the key things which students must do in order to score highly under the design criterion. They must present a range of alternatives for their observing program, rather than simply describing how they took their observations. Indeed, this should be completed in advance of the observations and written in the future tense. This is the assessment criteria for the observation criterion. These are the key things which students must do in order to score highly under the observation criterion. A full set of observational details must be included with each observation. This is the assessment criteria for the analysis criterion. These are the key things which students must do in order to score highly under the analysis criterion. A quantitative analysis will often help students to access the higher marks under this criterion. This is the assessment criteria for the evaluation criterion. These are the key things which students must do in order to score highly under the evaluation criterion. Students should also be reminded that they need to include some suggestions for improvements and extension work, as well as evaluating their observations. Students should use quantitative assessment of the accuracy of their observational data. These are some of the features of the best CA work seen during the 2015 examination series. Some excellent work was produced with some of the simple tasks, such as using a shadow stick or observing lunar features. Access to sophisticated equipment is not needed for high-quality observational work. High-scoring candidates ensured that their analysis section always referred back to the problem set by the task title, rather than just describing what can be seen in their observations. These are some of the features of the CA work which lost marks during the 2015 examination series. Candidates should try, whenever possible, to include a quantitative element in their evaluation, for example, calculating percentage errors in longitude or magnitude estimates. Candidates must remember to include a choice between several alternatives in their design section, rather than simply describing what they did. Candidates must check carefully that they have all the necessary observational details included with all their observations. Please look at the first piece of sample work, Unaided Shadow Stick. In order to get a good understanding of how the assessment criteria apply to actual pieces of work, we would like you to give this piece of work a mark out of 5 for design, observation, analysis, and evaluation, using the assessment criteria provided. This piece of work would have achieved 3 marks for design because this design section explains clearly what the student actually did, along with some simple explanations and justifications for their choices. Their choices are appropriate for the task, ensuring that the 2 to 3 mark level in the design assessment criteria has been secured. In line with the 2 to 3 mark band, some basic astronomical terminology has been used. With the possible exception of the length of the stick, the candidate has not presented a range of alternatives, or explained why their chosen location was the most appropriate, making the 4 to 5 mark band inaccessible for this piece of work. This piece of work would have achieved 3 marks for observation because the central determinant of the mark for the observation strand is the extent to which the candidate's observations support conclusions relevant to the problem posed by the task title. This candidate has taken shadow length measurements on each occasion which are adequate for the drawing of a curve of best fit. The student has repeated their observations 3 times, allowing an average to be calculated. Inspection of the range of resulting local noon times suggests that the candidate possibly has 2 readings and an anomaly, requiring further readings to support the calculation of a fully reliable average local noon figure. The candidate's choice of curve of best fit is consistently too low, leaving almost all points above the curve. In practice, this has not had a great effect on the estimation of local noon times. The above points point towards a program of sound rather than excellent observations, resulting in sound rather than conclusive data. That is, the 2 to 3 rather than the 4 to 5 mark band. All necessary observational details are supplied, supporting the choice of the mark of 3 rather than 2. This piece of work would have achieved 4 marks for analysis because the candidate has used a table to show clearly the stage in the calculation of longitude. A full quantitative analysis of the local noon data resulting in an average figure for the observer's longitude. A number of specific astronomical terms are used correctly, such as equation of time figures. The above points suggest that the candidate has satisfied the requirements for the 4 to 5 mark band. The slight concern over the placement of the curves of best fit on all graphs points towards a mark of 4 rather than 5. This piece of work would have achieved 4 marks for evaluation because the candidate has performed a quantitative evaluation of the accuracy of their longitude figure, resulting in a percentage error figure. As well as suggesting repeating their observations on further days to improve reliability, they have also identified the importance of taking more frequent observations on each occasion. They have suggested using electronic methods to improve the accuracy and consistency of shadow length measurements. The above points are characteristic of a clearly reasoned quantitative assessment and feasible suggestions, placing this piece of work just inside the 4 to 5 mark band. The rather short descriptions given in this section would need more detail to be classed as fully detailed suggestions, suggesting that a mark of 4 is most appropriate. These are the final marks for this piece of CA work, giving a total mark of 14 out of 20. The strengths of this piece of work, which helped it to gain marks, were made sensible choices in their design section, a good number of points taken on each occasion, a table used effectively to show the stages in their longitude calculation, quantitative evaluation giving percentage error figure, feasible suggestions for improvement. The areas where this piece of work could be improved were provide and fully evaluate a range of alternative locations in their design section, consider the spread of their repeated readings to investigate a possible anomaly, provide more accurate curves of best fit, provide more detail on each of their suggestions for improvement, perhaps supported by diagrams. Please look at the second piece of sample work, Aided Messier objects. In order to get a good understanding of how the assessment criteria apply to actual pieces of work, we would like you to give this piece of work a mark out of 5 for design, observation, analysis, and evaluation, using the assessment criteria provided. This piece of work would have achieved 4 marks for design because, as well as describing how they obtained their images, the candidate has discussed their choice of a robotic telescope over 2 smaller alternatives, using a number of astronomical criteria. They have explained how the low apparent magnitudes of many Messier objects make the large aperture of the Bradford Robotic Telescope most appropriate. They have discussed a number of advantages to the choice of the BRT, although most of them are not included in their table of comparative data. The above points are characteristic of the 4 to 5 mark band within the design assessment criterion. Many of their reasons for using the BRT are presented after the choice, rather than being considered for each of the alternative optical instruments in order to help make the decision. It would be possible to include a greater use of specific astronomical terminology or even calculations in this section. A mark of 4 is therefore the most appropriate. This piece of work would have achieved 2 marks for observation because the work presents a rather random collection of images. Some candidates attempt to follow a theme, such as presenting an image of each type of galaxy, each type of object in the Messier catalogue, etc. All the images are rather small and quite low in detail. Given the equipment being used, a better choice of target objects could have resulted in much more detailed images, making the selection presented here a little short of sound or adequate, resulting in a mark of 2. This piece of work would have achieved 3 marks for analysis because the candidate has sensibly presented a series of images showing the successive stages in the processing of each image. This involves the use of some astronomical terminology. Each stage is clearly explained, although the sample images are very small, making it hard to see any significant difference between some stages. The candidate has therefore used their images to address the task set, and can therefore be awarded a mark of 3. This piece of work would have achieved 3 marks for evaluation because the candidate has sensibly presented one of their images alongside a Hubble Space Telescope image of the same object, printing them at roughly the same size. They have not used very specific astronomical terminology when comparing the 2 images, often referring to the SHT image as being clearer, rather than using terms such as resolution, etc. They have correctly identified the importance of atmospheric distortions and telescope aperture in improving the quality of their images. This section is therefore sufficient for the award of 3 marks. These are the final marks for this piece of CA work, which would have scored a total mark of 12 out of 20. The strengths of this piece of work, which helped it to gain marks, were: they have attempted to decide between a range of alternative optical instruments in their design section. They have attempted to use some astronomical criteria to decide between these alternatives. They have presented a clear step-by-step illustration of how their images were processed. The areas where this piece of work could be improved were greater thought behind their choice of target objects, presenting a range of alternatives for other factors such as location, target object, etc., producing larger and more detailed images, perhaps presenting a NASA comparison image for each of their target objects. This is a list of some of the common ways in which students lose marks in their controlled assessment work, not including a range of alternatives in the design section, but simply stating how the observations were taken, not including enough or sufficiently detailed observations to address fully the problem set by the task title, providing only a very general analysis of the observations, which involves no calculation or detailed analysis, providing an evaluation which makes no suggestions for improving or extending the observations. Thank you for taking part. We constantly look to improve the training we provide. Please let us know what you thought of the training by completing our online feedback form.